Hello, this is Team 12 of the NASA Mars Lander project, which is Project 3 of the first year engineering lab. This presentation is for our group, Quetzal Construction. In this presentation, we'll be covering how our project went, going from the project's proposal to our conclusion, which includes the results of how our testing went and as well as evaluation on how we did. First, let me introduce all of you to our team. I am Kevin Couch. Then we have Matthew Gazzoli as our construction manager. We have Brett Fisher as another construction manager, and Sama Francois as our test and verification engineer. When we were first introduced to the project, here is the RFP we got. It includes information on what exactly this project is and some of the information we should know to complete this project to a satisfactory level. We were then introduced to the requirements the customer provided. It was a fairly short list, just a very quick detailing on what we were doing. If the next list of requirements that we got, though, from our contractor were much longer, and we got some valuable insight after asking the contractors what specifically they wanted, such as the testing conditions we would be under, and some other requirements regarding materials we could use. This next slide displays the rest of the contractor requirements.
On the first day of our project, we were tasked with designing at least or drawing at least 10 different designs for our project, which we then chose the top three of those, which with more detailed drawings, and then finally we decided on this one, which we then made a very detailed drawing with measurements. With this design, we formed an X shape by cutting slits into two 8-inch by 8-inch pieces of cardboard and covering it with a lid with a smaller piece of cardboard, which is seen on the bottom right as the X shape. And on the top left, you can see from the top view, which just shows the lid coming over the top of it. And on the bottom left, it shows the side view of our model, which has the two smaller, less than an inch squares that we use to strap on the lid using rubber bands. This is a list of all the materials that we purchased. So the first thing we decided that we needed was a large piece of cardboard measured 2 feet by 2 feet, which costed us $10. A square foot sheet of bubble wrap, that was $2 that we would use to put inside of our model, that in the trough sort of shape where the eggs would be placed, just use to cushion them. Four plastic grocery bags, which we decided would be good to use for parachutes, even though we only ended up using one of them. 10 rubber bands, which we use to strap on the lid to these smaller squares on the side, which we figure would make it very quick to take the pilots or eggs in and out of the design. And 10 cotton balls that we use for extra comfort inside of the trough, which was a total of $14. Here is all of our materials laid out on a table. So we have the 10 rubber bands on the left. We have our 1 square foot sheet of bubble wrap. We have 10 cotton balls, our four plastic bags or parachutes, and our 2 foot by 2 foot or 4 square foot piece of cardboard.
This slide here shows the step-by-step process that we use to construct our model. First, by just cutting the main cardboard pieces halfway down the middle and inserting them together to create the X shape. Proceeding to then complete the cradle model by cutting two triangles and holding the eggs in place on top, and then stuffing it with the cotton balls and bubble wrap, and then taping the lid onto the top with the rubber bands mechanism to keep the lid closed. Finally, putting on the parachute on top fully completes the model. This next slide is briefly describing the change that we took by only using one plastic bag parachute instead of four on each corner to try to maximize the amount of volume that the plastic bag is catching compared to four plastic bags just closed on each corner. This slide here shows the front, side, and top view of our model, showing the X shape and cradle, mainly in the front view, with the side view showing the rubber band locking mechanism that we use to close the lid and quickly and efficiently insert our egg pilots and um, leaving us with the top view, which pretty much just shows the parachute. So
Displayed on this slide is a documentation of our Mars lander test and verification plan. First on the checklist, we have the vehicle integrity verification, where measurements in centimeters was taken from different portions of the vehicle. For length, we have 8 inches, 8 centimeters. For width, we have 5.75 centimeters. And for height, we have 19.5 centimeters. Please note that within the height is included the full extension of the parachute. Next is the pilot integrity verification. The pilots, in this case the eggs, were checked for any cracks or any misshapes or errors within. Next, we have the timer. A 1 minute timer was set to load our pilots, and we were able to load our pilots in less than a minute, but the recorded time was at 11:09. Next, we have the first drop. After the drop, our vehicle integrity verification was the same as recorded before. We were unable to get a proper recording for the unloading time, but we were able to record that one of our pilots did not make the drop. Next, we have our revenue earned. We were only able to earn $10,000 since we were unable to complete the program with only one pilot. In this video, please keep an eye on the person wearing all pink, as that is our representative for our group. As shown in the video, our model flipped and landed on the top rather than on the bottom, which led to the results in the next slide. The eggs made direct contact with the floor, and since there were no cushion at the top of the model, the egg hit the top and broke. One of the eggs were able to survive due to more cushioning, but one of the eggs did break on impact.
So, over the course of our project, we had to go through many steps to get to where we are now. During our design process, it was fairly quick and fairly easy. We very quickly came up with designs that we thought would work, and among them were one of the final ones that you saw here. In order to construct this, it wasn't too difficult either. The design that we chose specifically was chosen because it was simple and it looked like it held enough promise. Unfortunately, when it came to our test results, given that one of our pilots had perished during the test, it was not as we had hoped. It flipping over was a very, very big problem, and we took note of this. So deliberated on how we could improve this design, we suggested that we could either lower the center of mass so that maybe the structure would not flip over preemptively, either that or make a larger parachute so that the drag on the vehicle would be greater and therefore it would stay upright while it is falling. All right, this is the end of our presentation. Thank you for listening, and I hope you have a good day.